In this video, we're going to do a bunch of examples together with some different diagrams so you guys can see what some different things look like. So in example 1, it says, name the following using the diagram to the right. So this diagram here is of two planes. We have a vertical plane right here, and then a horizontal plane, and then they intersect right there. So kind of think of like a book, right? An open book. That's what this would look like. So first thing we're being asked to do is identify 3 points. And I made a note for you to separate them with commas, because if you don't have nice spacing, 3 points could look like you're naming a plane. So we just need to name any 3 points. So look for 3 dots and write down the letters next to those dots, and it's that simple. I'm actually going to write down all of the points so that you guys know which ones are possibilities. So F is a point, E is a point, D is a point, A is a point, B is a point, and G is a point. The only letters you see here that are not points are H and C. Those are actually labels for our plane, and you can see there's no dot next to them. Name 2 lines. Well, I see 2 lines in our picture. We have a line here and a line here. Remember, when you name a line, you can do it in 2 ways. You could either pick 2 points on the line and put your double-sided arrow on top, or use a lowercase cursive letter. In this case, there are no lowercase cursive letters, so that's not an option. So we got to go with the points. So this top one, that would be line FE. Put your double-sided arrow on top. You could also call it EF. Order doesn't matter there. Another one would be line AB or line BA. So then for number 3, it says to name all points in plane H. Plane H is this vertical plane here. There are 3 points in it. That would be points F, E, and D. The other points that are in this picture aren't necessarily in that plane. It doesn't encompass them. And then it says to name the plane containing points A, B, and G. Well, here's point A, point B, and point G. So they're on that horizontal plane. Now, when you name a plane, you can either use 3 points that aren't on the same line or your uppercase cursive letter. I'm going to show you both ways. So we could call this plane A, B, G, or GBA, BAG, AGB, okay, just those 3 letters. Or you could also call it plane C, and I don't really know how to make a cursive C. It looks the same as a regular C, but you have that C there in the corner, so that's also an option for you. All right, next diagram, for example 2. It says name the following using the diagram to the right. So in this diagram, we have a plane. We have a line laying on top of that plane and a line going through the plane. It's going like into the top and coming out the bottom. Now with these, there might be more than one good answer. If you think of another option and you're not sure if it's right, just ask. So number 1 says to name a pair of opposite rays. There are 2 options that we could name here. Remember, opposite rays have to start at the same place and then extend in opposite directions. So if one goes up, one goes down. If one goes left, one goes right. So the first pair I'm going to point out to you is ray NT that starts at N and goes up towards T, and ray NW that starts at N and goes down towards W. They both start at point N. One goes up and one goes down in exact opposite directions. And then remember, when you name it, you have to start with the end point. So that would be NT with NW. And there's another option. I'll do this one in a different color. You could also go NP and then NM. So right NP goes to the right NM goes to the left. They both start at N, they go in opposite directions. So right NP and ray NM. And remember, when you name your ray, you need to have that single-sided arrow up at the top. Let me fix my handwriting here. Okay. Name 3 collinear points. So remember, collinear points, those are 3 points that are together in a plane, or I'm sorry, in a line. So 3 points on a line here. You have 2 different options. We could go with M, N, and P. Those are all sitting on that line. So M, N, and P, and you'll notice here I'm separating with commas, so we can tell those are separate things. Or we could look at W, N, and T. Those lay on that up and down line. It's not quite vertical, but the one that's coming from the top and going out the bottom. Those are all laying on the same line. So we could also say T, N, and W. Those are both options. Name the intersection of plane name the intersection of line TW with plane A. So if you look back up above, it says that a line and a plane intersect at one point. So we're looking for the point that they intersect at. So line TW is approaching our plane, right? It hits it and then it comes out of the bottom. So that place where it hits, where it intersects, is point N. So we would say point N. Number 4, a point that is not coplanar with plane A. That means it's not going to sit on the plane. There are 2 options here. Point T is hovering up above the plane somewhere, and point W is down below. So neither of those would be coplanar with anything else that's on plane A. So you could say T and W, and you can write point if you want. When you write a point, you can also just put the letter. That one doesn't matter. Another name for line NM. So MN, sorry, I read that backwards. Another name for line MN. So MN. Here are those points. That means it's talking about this line, that horizontal line. So remember, when you name a line, you could either pick 2 uppercase letters or a lowercase cursive letter. Well, point P is also on that line, so you could use P to name it. It would all be the same line. So maybe we could call it line NP. That would be an option. Or line PM. Oh, and when you have a line, you need your double-sided arrow on the top. Those would all be options. There's probably more. You can also use your lowercase cursive letter and call it line S. That's my best cursive S for you today. And then 4 coplanar points. So those are 4 points that are going to lie on the same plane. You have plane A pre-drawn for you here. So the easiest way to answer this question is I would just pick 4 points that are laying on that plane that are not in a straight line. So that would be M, V, N, and P. M, V, N, and P. Now, something I just want to give you a heads up on, because it does come up at some point. Remember, a plane is any flat surface. So think about, is there anywhere else I could draw a flat surface here, or any other points that could be connected with a flat surface? And the answer is yes, because vertically you could connect M, T, P down to W here. So you could technically also have a plane connecting those points vertically. It's just not drawn on your picture. So that's just something to keep in mind. All right, one point that is not coplanar with points M, N, and V. So M, M, N, and V. So not coplanar with them, that means it's not sitting on the same plane. You would not pick P. P is on the same plane. You could pick T or W. Okay, and then the last example, I know this is a lot of examples for this one. I just want you guys to see as many kinds of pictures as possible. So example 3, this picture is a little different here. This is a cube, and a cube is actually just made up of a bunch of planes, lines, and points. Each face of your cube here, so the top, bottom, front, back, these are all planes. Those are flat surfaces. The edges of your cube are lines or line segments. Technically, they're drawn as line segments because they end. And then all your corners are points. So name a point that is coplanar with points A, D, and G. So A, D, and G. We need to name something coplanar. So A, D, and G are actually three of the corners of that bottom surface, right? The bottom of your box here, the bottom of your cube. So the other points that would be coplanar with it have to also be on the bottom. So you could name L or F. Those all technically lay on that bottom plane. So we could say L and F. Name the intersection of plane HEG and plane DFE. So for this, if you have like some highlighters or something at home, this is kind of nice to color for yourself. So plane HEG, HE, and G, those are all laying on the back of your cube. So it's this back surface here, that's that plane. Okay, so if you outline those, you can kind of see there's your plane in the back. Plane DFE, D, F, and E are on the right side of your cube here. So here's that plane. And what's nice when you highlight it for yourself is you can see where your colors cross over. And that shows you your intersection. So if you go up above on your notes, it says 2 planes intersect at a line or a line segment in this situation. It just happens to be the drawing. And you can see that they intersect at segment or line EF. So that would be our intersection there. Segment, and I'm going to just put segment because that's how it's drawn in this picture. So segment EF or FE. Name a point that is collinear with BH that should have a little segment or line bar on top of it. That's just a little typo here. So this should have a little line. And again, I know this doesn't have the arrows, but you have to remember that they technically extend on forever. So name a point that's collinear. Well, B is here, H is here. So the only other point on that line would have to be M. So that would be point M. Name a point that is not coplanar with C, E, and M. So let me erase some of what I have here. Okay. So a point that is not coplanar with C, E, and M. Sorry. Okay. C, E, and M are all on the top of your box. You could really name anything that's not on the top. That means B is out, H is out, and you could name anything else. So take your pick from G, L, F, D, and A. Any of those could work. And then last question, name a point that is coplanar with points B, H, and D. So B, H, and D. And here's where I might lose you a little bit because you're like, wait, B and H are up the top. D is on the other side at the bottom. I don't see how those could connect. Well, remember what I mentioned in one of the previous examples. Yes, some planes are going to be drawn for you, but a plane is anything you can connect with a flat surface, and this is a cube. Imagine if you sliced your cube diagonally from BH down here to DF. Well, you would have a little like slanted plane there. So technically, those could form a plane, and point F would be coplanar with them. That's something nice to remember for one of your assessments that'll happen eventually. So that's it for your notes today. Feel free to rewatch, fast forward, rewind as you see necessary. And then I am happy to take questions when I see you guys in class, or hopefully I'll also be able to set up a Google Meet for the remote learners. Email me if you have any questions, and have a great day.